through this. So we got to, yesterday we got through cluster sampling. Okay, so the next one is stratified. So we did cluster. Let's do stratified. Here we go. Stratified is where we divide it. We have small, medium, and large rectangles. So the method is to divide into homogeneous. That's an important vocabulary word that you need to associate with this, which means
The same.
the same. Divide into homogeneous groups. After you divide into homogeneous groups, then what do you do? Randomly choose what? Like if I divided into 9th grade, 10th grade, 11th grade, and 12th grade, how would I, so that's stratified by grade, then what would I do? Choose one or some. I could choose one or some from all the groups. Choose some, one or some, from all the groups. Okay? Good. Advantage is that we make sure that we get what? Okay, representation of all types. Good. So the advantage is that we have all types represented. So we're making sure that we're getting all types represented. The disadvantage? I've gone blank. A disadvantage. Oh, I know. It may be difficult to know which trait to stratify. For example, I want to know the favorite color of Aledo High School, or the proportion of favorite colors, whatever. So I'm going to divide you into 9th grade, 10th grade, 11th grade, 12th grade. I'm going to randomly pick 15 of each grade. Okay, and so there you go. But what if, because this could happen just by pure randomness, I happen to get 15 girls from the 9th grade? Okay, could that potentially make my results unrepresentative of all of Aledo High School?
Yeah.
Yes. So then I say to myself, ooh, I think gender is going to affect color choice more than anything, so I should probably try to control the gender and make sure I get an equal number of boys and girls. Okay, so you see the problem? I need to have, it may be difficult to figure out how to group so that you are controlling what you need to control in your groups. Okay, good. Next thing, I want to show you an easy way to remember the difference between cluster and stratifying. Those are the most frequently two confused ones. I get flip-flops, people can't keep those straight. So here we go. Cluster was when I took all of the advisory periods, I put them in a big bag, shook it, pulled out 3 advisory periods, and when I pulled out an advisory period, I asked how many people in that room. All of them. That's what clustering is going to do. You're going to ask all subjects from how many groups? Some of the groups. So with clustering, you ask all, everybody in, some of the groups, as opposed to stratified. Stratified, think of 9th, 10th, 11th, and 12th. I picked what? I picked some subjects, so I picked some people from all groups. Okay, so up here I had this nifty little thing, all from some from all, and yeah, that's nice, good and well, but how do you know which one goes with which? You know, oh, I kind of know, one's some from all and all from some, but here's how I remember. If I was a student studying this, here's would be my little goofy way of remembering this. Sum from all goes with stratify because it's the S. So sum from all goes with stratify. And then all is the A is closest to the C in the alphabet, so there, that one's with that. Okay? All right, so that's kind of like my little memory device to help me remember which one's all from sum and which one's sum from all. Okay, next, systematic. The key that gets frequently missed with systematic is that you start with a random spot, and then you choose. What do you do with the systematic? You're choosing every what? Certain number. 10th, every 5th, every 20th. Okay, so every, and this is the general way to do that, nth, 20th, 15th, whatever. Oh, that's my memory to remember to do attendance, and I already did it. So choose every nth item. Okay? The advantage is that it is easy and quick. The disadvantage is that you may have an unknown cyclical, like a cycle, pattern. Okay, and the way you will remember that is I'm going to do this really pretty little rainbow. So remember my little rainbow picture, and this will help you remember the problem with that. It's going to be oversimplified to demonstrate the problem. So here's my pretty rainbow. There's one. I'm going to have 5 layers here. 2, 3, 4, and then 5. Okay. I'm going to pick a number randomly, random starting point. Pick a number randomly between 1 and 5, and I do it on my generator, and I get the number 2. Okay, so guess what? I'm going to start with a smiley face, and then I'm going to do every 5th one. Well, here I go. 1, 2, 3, 4, 5. Ta-da! Where did I end up? Smiley face. Here's the next 5. 1, 2, 3, 4, 5. Ta-da! Where did I end up? Smiley face. So if this was like in the dark and my eyes were covered and I keep doing every 5th one and I keep getting smiley faces, I think all that's in my population is smiley faces. And is that representative? No. Okay, so there you go. All right, the last thing, which actually is not on your page, is census. So write this down at the bottom. Census is what I did when I averaged the whole entire 100 rectangles. A census is when your sample is the population. So I did the whole thing. U.S. Census, we attempt to get data on all U.S. residents. The advantage is that you think you're getting something that is definitely representative of the population because it is the population. Okay? So we know that it is representative. What is a disadvantage? There's actually 2 main ones I know. What? Oh, that's a good one. Time. What else? Oh, big time bucks. Big bucks. In 2010, after Obama was president, and we saw, in 2010, we saw the unemployment rate plummet. So everybody thought, woohoo, economy's on the right, economy's recovering, yada, yada, yada. Well, in 2010 is when we did the last census, and there was a lot of people employed to be data collectors. Okay, so they were employed by the government to collect that data. Well, after that went away and they were done with that, then we had those unemployment rates back up. Also, remember, I got 7.49 and another teacher got 7.42, so it's typically not completely what? Accurate. Accuracy is an issue. Okay, all right, so that's the last thing about sampling. I want you now to pull out the page that we started yesterday. That was this one, and we did not talk any about the top at all either. Okay, so here we go. Oh, we did talk about the letters? Yay. Okay, very good. We did talk about the letters, and we said that letters that represent samples are called what? Statistics. Letters that represent populations are called parameters. When I did the entire average of all of the rectangles, it was that mu equals 7.49 because it was for all of the rectangles. But when I just did a judgment sample, the sample of my one little 5 things was 9.6. See? This was when I just sampled 5. This was when I averaged all of them. Okay. Now, and then we've already talked about the importance of the random rectangles. Now, the next question is, does size matter to the sample? Does the size of the sample matter in your attempt to get the correct random or the correct representative sample? Okay, so we're going to go to here and watch a little video that represents that. It is kind of like a how it's made video. I like those. It's going to be bad quality, but it talks to you about how they do sampling at the Frito-Lay company to determine if the truck is a quality enough truckload of potatoes. So here we go.
A truck filled with potatoes pulls up to a Frito-Lay plant in Killingly, Connecticut. From the point of view of the people at Frito-Lay, these potatoes are the population. We want to know whether the potatoes in the truck will make good chips. Each truckload carries about 45,000 pounds of potatoes. That's far too many for the inspectors to examine individually, and even if they could, it would produce too many mistakes due to human error. Instead, they take a sample. An inspector fills a 30-pound bucket with potatoes at 5 different points down the length of the truck. Frito-Lay can get better information by studying this 150-pound sample than from any attempt to inspect the entire truckload. First, the inspector randomly selects 40 pounds of potatoes and punches a core through each one. The hole down the middle makes it easy to spot the chips when these potatoes undergo a cooking test. Now 10 pounds more are set aside, leaving an even 100 pounds on the table. The inspector searches for internal defects, green edges, mechanical damage, and other flaws. Each defective potato is weighed. If the fraction of the sample that is defective is too large, the whole load must be rejected. Meanwhile, Rita has peeled the cooking sample so she can toss them directly into the slicing machine. From there, they become chips. Then, she plucks out the sample chips and delivers them to a mini laboratory right on the plant floor. Less than 45 minutes later, Rita has both the results from the cooking sample and the inspection data. Everything meets specs, so based on a sample, Frito-Lay will accept this shipment.
There you are, Willie, Mike. Excuse me, guys. Nice lot of potatoes. You can go ahead and weigh up, put your truck under for number 2. Ready?
This lot of potatoes is on its way. The receiving department has approved the entire 45,000-pound shipment from a representative sample of just 150 pounds of potatoes.
Okay. What's the population? The 45,000 pounds of potatoes on the truck. Okay. What's the sample? The 150 pounds that he got from 5 places along the bed of the truck. What kind of sampling method is that if he's taking that from those 5 different places along the truck? It is stratified by location in the truck. The truck was split into 5 different sections, and he took some from each section of the truck. That is stratifying. Some from all the sections. Okay. Hey, did you see what did they do so they could see which potatoes were in the sample to fry them? What did they do? Okay, they poked a hole in them. So I always want to get a bag of potato chips and then pour it out and see if any of them have a hole in it that came from that sample. So okay, goofy like that. So then they choose from that whole sample whether to reject or accept that whole entire shipment. Because is Is it more accurate to do the information from that 150 pounds than the whole entire truck? There will be too much what with inspecting the whole entire truck. Good. Okay. So next is going to be this little video about something else. If I can get this closed. Okay. All right. So this one is going to talk about the size of the sample and what size it needs to be in relationship to the population size. Let's see if that's what. I think it's thinking. I don't know. I think that. Here we go. Okay. Sorry.
We have seen that large samples tend to be more like the population from which they are drawn than smaller ones. It is natural to think that this is because a larger fraction of the population.
Okay. See, I opened it twice. No, I opened twice, and so it was like one right after the other, so it was like this echo effect. Okay. Yeah. Okay. So let's see what we got here. Okay, I'm going to narrate. We have 2 bowls of soup, and they want to take a sample and test the saltiness in the soup. So they mix it up. So they randomize the soup, and then they take a spoonful out, and then they sample it. Okay, and they taste it, and then they can tell the saltiness and if it's good or not. So now we have the larger bowl of soup. In order to test the saltiness in the larger bowl of soup, do we need to pick a larger amount of soup out of it, say a ladle full of soup? Or is it sufficient to get something from just the spoonful still, even out of the larger pot of soup? Okay, so the sample size does not matter as long as, then this next demonstration is going to show a toothpick of soup toothpick going into the bowls of soup. When you put a toothpick in there and you pull it out and you try to taste it, is that going to be adequate and sufficient to allow you to taste the saltiness of the soup? No, it's too small. So the size of the sample does not matter as long as it is representative of the population, as long as it's enough to be able to get a sample. So, therefore, let's hope this closes. Aha. Yay! Okay, now, let's see if my... okay, so go to that part on your notes that says, does sample size matter? And so then we're going to write in that space there, but I'm having trouble getting to it. Okay, I know, it's like so slow. It's crazy lagging. Okay, I'm going to just close it. Okay, so the answer is, does sample size matter? And the answer is, I'll just write it here. No, sorry, you can't read that very well. No, I'm not going to use red.
Or green.
Okay. Man, this is crazy. Oh yeah, I can write right there. Okay. Does sample size matter? The answer is no. As long as the sample is representative of the population. That's what you're writing on your notes. Does sample size matter? No. As long as the sample is representative of the population. Okay, let's see if we can get this closed out. All right, next I want to talk to you about some types of bias. There's also two other types of sampling, and one of them is down there at the bottom, and it says, okay. No, well, aha. Okay, now, let's open this up. And I'll tell you what it is. It's whenever I try to play the videos, it, like, can't do that and record at the same time, because I'm recording. So that I can, so I can put it on for my absent people. So,
Stop that
that's
virtual.
what it's freaking out.
That's not allowed.
Hear us too?
Yes. Okay, it's for the volleyball people and the absent people. Okay, so, hey, while we're talking, look down there at the bottom. It says convenience sample. So let's keep going while this is trying to open up. Convenience sample. The words that go with that. The convenience sample means that you are choosing your sample because it is easy to get the subjects. You are choosing your sample because it is easy to get the subjects. All right. So I have a little video that I want to show you, but I can't because my computer is in freak out mode. So I'm just going to tell you the story, okay?
To get the what?
Okay. It's easy to get the subjects. You know, like if you're going to ask people, then okay, so then it's easy to get their phone number if they were on a list or whatever. Okay. So here's the little story. We'll have story time. Okay, you ready? Literary Digest, 1930. Okay, think back. Literary.
1930? I wasn't alive.
They had letters back then.
1930. What's going on in the 1930s? The Great Depression. Okay, so there's a significant gap. You got people that are have some wealth, are fine, can't have the luxuries such as buying a magazine, and you have a larger portion of the nation that is just searching for food. I mean, just trying to survive. All right. So what happens is the Literary Digest, generally they'll try to predict what happens in the upcoming presidential election. Well, in 1936, the upcoming presidential election was between Alf Landon, I think, and Theodore Roosevelt. Roosevelt, who was the incumbent, he had been president. Okay, so the Literary Digest sent surveys out to 10 million people in the United States that it got from people that had purchased vehicles or from phone numbers, people that had phones. Okay, so right now that should be triggering something. If we're talking about people that have cars and people that have phones in the Great Depression, is that going to be representative of the whole nation? No, it's going to be a smaller portion of the population than it is today. All right, so they predicted they got 2.5 million responses back. They got 2.5 million replies. That's huge. Okay, that was the biggest response that they've ever had in their predictions. And it predicted that Landon would win with 57% of the vote, and Roosevelt would have 43% of the vote. Okay, so they predicted that Roosevelt would lose, Landon would win. Okay, then there's this other guy. His name is George Gallup. Have you heard of that name before? Gallup? Yeah, the Gallup polls. You know, like whenever they're having presidential things and they want to say approval ratings or whatever in upcoming elections, different things, it's the Gallup poll. They call 1,000 random people. Anyway, George Gallup, he polled 50,000 people, and he surveyed 50,000 people throughout the nation, and they said that 58% were going to vote for Roosevelt. So George Gallup predicted that Roosevelt would win. George Gallup was criticized because he only asked 50,000 people. And the Literary Digest got responses from how many people? 2.5 million. Okay. Well, guess what? Come election time, do you know who won? Who won? It wasn't Landon. We've not had that president. It was Roosevelt again. He won by like 68%, to 42%. Crazy a lot of, he won a lot by a large margin. The size of the error of the Literary Digest was staggering. Okay, that's what the video says, so I'm just kind of... I've been hearing it 5 times today, okay, so I can pretty much say these things by verbatim, okay? Yes. The size of the discrepancy was staggering. The Literary Digest was so off on their predictions. They ended up actually later going out of business and turning into the Reader's Digest, but okay. So there was 2 fatal flaws in their design. Number 1, they only asked people that had cars and that had phones. That really basically gives you undercoverage. Oh, we haven't talked about undercoverage yet. Okay, but I'm going to in a minute. It gives you this thing called, it gives you this thing called undercoverage because what? What is that means only the people that had phones and cars got chosen. That means not all types of Americans were picked. Okay? The second thing is that they asked for people to send back their responses. That is called voluntary response bias. Okay, and we're about to write that on the back of the thing whenever I can get that to open. Voluntary response bias. So voluntary response bias means, how was their sample made? Their sample was made because people sent back their response. And you know why that's always biased? Because only the people that feel very strongly respond. Roosevelt was the incumbent. And so the people that did not want Roosevelt to win sent back their response saying they wanted Landon to win. So that's why it overestimated that Landon was going to win. And this is so annoying that I can't open this up. Look, it's like trying. It's about to maybe. Please, please, please. Okay. So, that's what happened with the Literary Digest. Yay. This is just ridiculous. Okay, so that's what happened with the Literary Digest. So, let's define a couple of those biases that you have on the back. One of them is, what's the top one? Undercoverage. Okay, what is that? What's the definition of that? Okay, here's what we're going to do. Oh, thank you. Okay, this is your homework that we're not to yet, but we are going to go over some of this. So make sure you pick that up in the front. Let's go over still defining undercoverage. We're not on this page. Okay. You know what? The recording is going away because I can't even teach. This is super annoying. Stop. Okay, pause. Okay, pause. Pause. No, I'm not playing it. Playing would be pushing that. I guess I'll go ahead and stop it. But then I have to wait for it to...